Okay, we are on lesson 6.3, summation. The idea of this lesson is to really look at how to use the summation notation to help us figure out the area under the curve and to add up rectangles without actually having to write out each addition equation, to write it in a much quicker manner, right? So let's go ahead and look at this. It says that you're finding the area under the curve using inscribed or circumscribed rectangles, right? So you have this curve here, and we are telling that this is the equation of 16 minus x squared, right? And right now we're looking in the interval between 0 to 3. So I'm going to say this is 3 because we know that 4 is where it's going to cross the x-axis there. So we're looking between 0 to 3. So 0 to 3. So 1, 2, well, not very good. Sorry. 1, 2, 3, like so. All right. And it says, let each interval have the width of 1/2 in the interval of 0 to 3. So to make this even smaller, we're going to cut this into 1/2 so that you have 6 rectangles here, right? So you're looking for inscribed or circumscribed rectangles. So you have your inscribed rectangle by going up and hide right underneath the curve, right? It should touch the curve right here. And then your second rectangle going up, touch the rectangle. Third, touching the curve. Fourth, this is your inscribed rectangle, like so. So here are your 6 rectangles, right? So the rectangles are width times height. Width times height, you can add them all up. A quicker way of doing this would be to take all the, factor out all the width to the outside. So you have your area equals 1/2. And then you need to take your y values, right? So what are your y values? Well, your y values are the values at 1/2, 1, 3/2, 2, 5/2, right? So where are these? You take these numbers and you plug them into your function of 16 minus x squared. So 16 minus 1/2 squared, so 16 minus 1/4, that would give me 63 over 4, right? 16 minus 1 squared is 15. 16 minus 9 over 4, so that's 64 minus 9, that's 55 over 4. And then 16 minus 2 squared is 12. And then 16 minus, where am I? Oh, 5 over 2. So 5 over 2 is 25 over 4. 64 minus 25 is 39 over 4. And then the last one will be 3. 16 minus 3 squared, that is 7. Right, so that will be your area. And then if you add them all up, you will get 1/2 times 293 over 4, which gives me 36.625 for my inscribed estimation here. Now, as you can see, my inscribed estimation, I'm underneath the curve, right? So you know this is an underestimate. So we're going to look at circumscribed. Circumscribed then starts same between 1 and 1/2. It's going to go right out here, using this endpoint to make my height, using this endpoint to make my height, go all the way down. Same thing, same thing, same thing, same thing, all the way down like so. So you see how my circumscribed is completely outside the curve, and it's going to be a little bit of an overestimate, right? Okay, so in that case, then my area is going to change a bit. So my area is equal to 1/2. Let's add my y values. So I start with 16, 0 over 4, 15, 55 over 4, 12, 39 over 4, and so on. So I get 1/2 times so 329 over 4, which then 29 over 8 gives me 41.125. So you can see that one is an overestimate, one's an underestimate. So maybe a better way to do this is find the average. So the average would be 38.875. Okay, so that's an average, and we'll find out in a minute if this is a good enough average or not. Okay. So what happened here is that I took the width, right? And the width is taking your interval of b minus a and divide by n, and it's the number, number of rectangles. So in our case, we have 6 rectangles. So we take 3 minus 0 over 6. That gives me 1/2. That's how I know the width is 1/2. It's also given to me in the problem here, but sometimes they don't give that to you. So you got to figure out what the width is based on how many rectangles you have in your interval, right? Okay. So the area is really taking your b minus a over n, that is your width, and that is your change in your x, right? So change in your x, right? And then times your f values. So f of, and this is your x0, because that is the first starting point, right? And this is your x1, x2, x3, x4, x5, and x6, because there's 6 rectangles. So for us, the right-hand side, the inscribed rectangle really started at f of x1, right? So you have f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5 plus f of x6, right? So that's your area. So what is different than the other one, the circumscribed, is that your y value started at x0 and went up to x5. Okay, so that's the difference between these two. So what does the k do? Well, the k in our equation here tells me to go from the next, go from this current y value to the next y value. It goes from this x to next x. So k equals 1 tells me I'm at x equals 1. And then summation says then you go to x equals 2, x equals 3, x equals 4, until you finish up to n, which is 6. X equals 5, x equals 6. So then this one, it still starts at x sub k equals 1 over here, but you start at k minus 1. So k minus 1 is 0. And then you go 1, 2, 3, 4, and then the 6 minus 1 makes me stop at 5. So that's what the k does. It helps you move on to the next value in the term without you actually having to write out each of the term. It helps you move up in the t table. Okay, so let's assume we have infinitely many rectangles. What is it going to do? How is it going to change, right? So we agreed that the width of my rectangle is b minus a over n, right? So if I have infinitely many rectangles, you still are ending at 3. By putting infinitely many rectangles in here, you have 3 minus 0, that's your interval, over n. So your delta x is going to be 3 over n. Okay. Now, how am I going to move on to the next one? So you have infinitely many rectangles here, right? If each width is 3 over n, then the next one is 3 over n times 2, right? Because that's 6 over n. And then 3 over n times 3, 3 over n times 4. So notice it's 3 over n times k, because that's where the 1, 2, 3, 4 comes in. So that's how you get the next x value. And then to get the y value, take these x value, plug it into your function. So you plug in 3k over n into your function. That's your height times the width of your rectangle, which is 3 over n. Okay? And since my function is 16 minus x squared, this is my x squared. So then that's how you plug it into the formula, right? Okay, so it says, remember that 3 over n is a constant. Use the summation formula to clean this up. So first thing I'm going to remind myself is that this is 3 over n. This is a constant, so I'm going to put it outside. And you have k equals 1 to the n. Now I'm going to clean this up a bit by actually multiplying this out. 3k over n squared gives me 9k squared over n squared. Okay, remember, we can separate our summations. So I'm going to make it so it's summation of k equals 1 and k squared over, the term 9k squared over n squared. Okay, and then if you recall, your 9 over n squared, that's still a constant, that's a coefficient. So I'm going to pull it outside. 9 minus n squared, summation of k equals 1, k squared. Okay, so this is where it comes in. Your formula to the left-hand side here gives you all the summation equations here. So if you have a constant, it becomes n times that constant, right? So my equation here now becomes 3 over n, 16 times n So that's the formula, 16 times n, the constant, right? And then minus 9 over n squared. And your formula for this piece, that's this one right here, it gets replaced with n times n plus 1 times 2n plus 1 all over 6. Okay? All right, so now the rest is algebra. Let's clean this up. Your goal actually is to rewrite these as individual fractions, and we'll find out why in a minute. But if you rewrite it as individual fractions, this will work out really nicely. Okay, so I'm going to keep 3 over n outside for a bit. I'm going to clean this up on the inside. So I get 3, this gets reduced, over 2n times n. I'm going to distribute that, so 2n squared plus 3n plus 1. Okay, so now I'm going to distribute this. I get 48, the n's reduce out, minus 3 times 2n squared over n squared. So there's a lot of distribution here. I'm distributing the 3 and then the n, okay? So I get 3 times 3, that's 9, and then n squared over n squared, and the 2's cancel out. So I get 9, reduces out, sorry, minus, okay, now this one's going to be a little bit tougher. I have the 3 times 3 times 3, so that's 27, n over 2 over n squared, so it's over n, minus 3 times 3 is 9 over 2n squared. Okay, now keep in mind, what is the number of n? The number of n is infinity. So limit as n approaches infinity, because we're trying to get the number of rectangles to approach infinity. And so in that case, then any number that's dividing by n is going to be approaching 0. So my final answer is 48 minus 9, which is 39. That's my actual area. And my approximation upstairs was 38.875. So my approximation is actually pretty good in comparison to the real one. Okay. So 2 key things to remember is that if your function is increasing, like so, it's increasing, then your function should be like this. Then your inscribed is going to start at k minus 1. That's your inscribed. Because it's going to start here at 0, right? K equals 0. If you're circumscribed, you're going to actually start here at k. So k is circumscribed. If your graph is decreasing, then k minus 1 is circumscribed. And your k is inscribed. I did not still spell circumscribed right here, sorry. Circumscribed. Okay? All right, that's it for this lesson.